Two circles each have a radius of 10. They overlap so that each contains exactly 25% of the other's circumference, as shown. The area of the shaded region is closest to. I would like to make this a bit bigger since this diagram is at the heart of the question, and I think that's sufficient. Okay, so the first thing I want to draw is the center of this circle, and I'll draw lines to that point and lines to that point. Now, this piece of information is important. They overlap so that they each contain 25% of the other circumference. So that means this segment represents 25% of the total circumference all the way around, like that. What that basically means, the interpretation of that, is that this angle is 25% of the total angle. Now the total angle all the way around is what? 360, right? So this angle right here has to be 25% of that. And if you do that math, you get 90 degrees. And that's why I put a little right angle there. So now we are in a better position to calculate that shaded region. First thing I'm going to do is drop a line to cut that shaded region in half. And when I do, I will label one of that shaded region A. And that's A and that's A. So I'll just leave that labeled as A, and therefore the shaded region is the equivalent to finding 2A. First we'll calculate A, and then you can just multiply it by 2 later. So how do we calculate A? A is calculated as follows. First and foremost, you take this area, which is sort of that pi segment, right? And that pi segment is basically the area of the circle divided by 4. It's a quarter of the circle. That's what that 90 degrees helps us to determine. Once you find that pi segment, from it, subtract this triangle. If you do that, you'll get A. Now, how do you figure out the area of that triangle? Well, it's 1/2 base times height, like that. And I think most of these things we know. So pi, obviously we know r is 10. And then 1/2 base times height. Well, the base and the height, if I call this, say, the base and the height, both of those are the radius. So one is 10 and the other one's 10. And that's it. So this is going to be 25 pi minus 50. And that's A. Now, of course, I want to figure out 2A because the area of the shaded region is 2A. So that's going to be 2 times that, which is obviously 50 pi minus 100. And that is equal to approximately 57. And of the answer choices, the closest is choice A. The trapezoid shown has a height of length 12, a base of length 16, and an area of 162. What is the perimeter of the trapezoid? First thing I'm going to do is drop a perpendicular from that down to there, making this basically a rectangle and a triangle. This is 12, and this whole thing is 16. I'm going to label this x and this 16 minus x. Now, the area is first the area of the rectangle, which is 12 times 16 minus x. And then the triangle, which is 1/2 base times height, 1/2 x times 12. And they told me the area is 162. So I put the 162 there. Now let's expand this. This is going to be 192 minus 12x, and that is just 6x. So this becomes 30 minus 6x is 0, so 6x is equal to 30, and therefore x is equal to 5. And what are they asking for? The perimeter. Okay, so the perimeter, let's fill all these in now. If x is 5, this is obviously 5. This is going to be 16 minus 5, which is 11. And therefore, this over here at the top would be 11. And then the only thing we don't know is that one, but that one we can figure out with Pythagoras. Let's just call it h for hypotenuse. So 12 squared plus 5 squared is h squared. So that's 144 plus 25 is equal to h squared, and therefore that's 169 is h squared, and therefore h is 13. And now we have all the sides, we can figure out the perimeter. So we got that 12, this 11, this 11, that 12. Oh, that one you don't need. Ooh, good thing I noticed that. But I need this one, that's 5, and then this one, 13. Okay. All right, so this is what, if you add this up, 52 for the perimeter of that shape, and that would mean that is choice B. B is on QS with angle QRT equal to angle SRT. Suppose that QT is M, TS is N for some integers M and N with N greater than M, for which N plus M is a multiple of N minus M. Suppose also that the perimeter of triangle QRS is P, and that the number of possible integer values for P is M squared plus 2M minus 1. The value of N minus M is. Let's do some labeling. Let's call this side RQ equal to X, and this side RS equal to Y for now. The very first thing is I've got to label this theta and this theta. So immediately, since that line RT cuts that in half into two equal angles, I immediately think of the angle bisector theorem. And that is going to give me as follows. X over M is equal to Y over N. Directly from the angle bisector theorem. No tricks at all. And then I think I'd like to put the M and the M and the N together. So M over N is equal to X over Y. Well, if that is the case, then that's very helpful because I can call X and Y in terms of M and N. So X could be some multiple of M, and Y could be some multiple of N. N. As you can see, the K's would cancel, and it would just give me M over N. So Y I'm going to refer to as Kn, and X I will refer to as Km. Now, we are going to use something called the triangle inequality, which I'm sure many of you know. Two sides have to be greater than the third side. So let's see here. I will compare this side and that side. So that's X and Y. So X plus Y has to be greater than the third side, which is right here, which is M plus N. And instead of putting X's and Y's, I'm going to put the Km plus the Kn values greater than M plus N. Factor out the K and you get M plus N is greater than M plus N, and that basically means that K is greater than 1. Now I will use the triangle inequality again, but this time two different sides. I will compare this plus this to be greater than the third side. So it would be X plus M plus N is greater than Y. Well, again, instead of X's, I'll put Km plus M plus N, and then instead of the Y, I'll put the Kn. So this becomes M plus N is greater than Kn minus Km, and I can factor out a K, and when I do, it will be N minus M, and I'll just bring that into the denominator. So K is greater than N minus M plus N over N minus M. All right, so that's pretty decent, I think. Now let's start talking about the perimeter, which is something they are putting a lot of emphasis on in this question. The perimeter of this triangle, just based on what we have up there, is X plus Y plus M plus N. And the perimeter in terms of K's and M's, X is Km, Y is Kn, and then this is M plus N. And I think I can factor out something. I can factor out the K. This will be M plus N. This will be M plus N. Factor out the M plus N, and I get K plus 1. All right, so now let's discuss this. We have some very helpful inequalities up here. The first one tells me that k is greater than 1. So since k is greater than 1, that means that the perimeter must be greater than m plus n times 2, because k is greater than 1, so that has to be greater than 2. So therefore the perimeter has got to be greater than 2 times m plus n. Also, another thing that we know that p is an integer. So since p is an integer, p has to be at least, so greater than or equal to this plus 1. So 2 times m plus n plus 1. So for example, if this was whatever, 12, and p is greater than 12, p has to be at least 13. And that's all that is, really. Nothing too complicated. All right. Now let's talk about this inequality. Since k is less than m plus n over n minus m, that means that this can be looked at in a very kind of similar way, that's equal to p. So that means that p is less than m plus n times this. We're going to substitute for that. So it would be m plus n over n minus m, and then don't forget about that plus 1. And in a very similar way, since p is an integer, p has to be less than or equal to m plus n times that m plus n over n minus m plus 1 minus 1. So for example, if this was, say, 14 and p is less than 14, p has to be at least 14 minus 1, which is 13. So that's why we put in that negative 1 there. Okay, well, these two things, this one and this one, give me a range. Combining, it gives me a range that p is between. It's either less than this guy, p m plus n times m plus n over n minus m plus 1 all minus 1, or it's greater than this guy, which is just 2m plus n plus 1. Okay, so for example, let's say the numerical values were 50 and 25, and I asked you, they're all integers. How many values does p have? Well, they're all the integer values from 25 to 50 inclusive. So the total would be, 25, 26, 27, all those guys. And you'd easily calculate that by doing 50 minus 24. So in the same way, if I said, how many integer values are there for that range? It was the same thing. You take this and subtract from it this, and then subtract one more. Exactly how I did there. So the number of values of p would be this guy, which is m plus n times m plus n over n minus m plus 1 minus 1 minus this guy, 2, let's just put it in brackets, m plus n plus 1, and then don't forget to subtract 1. So minus 1. Exactly like I did for this right here. And then they told me that the number of values of p is equal to something in the question. The number of possible integer values for p is this, m squared plus 2m minus 1. So that m squared plus 2m minus 1 is essentially what this whole thing is equal to. So I'll put it here. M squared plus 2m minus 1. And there you go. This is what we have to now simplify. And there you go. There's a simplification. I don't think you want to hear me go through all of this. That would be very painful. I encourage you to do this on your own, and when you do, you get to this very nice result at the very end. That 0 is equal to m times n minus m minus 4. Well, m and n represent distances, so m obviously cannot be 0. So that means that n minus m minus 4 must be equal to 0. That means n minus m is equal to 4. And that is what they wanted you to figure out, the value of n minus m. It's 4, and therefore the answer to this challenging question is A. A wheel with radius 1 is rolled in a straight line through one complete revolution on a flat horizontal surface. How many meters did the center of the wheel travel horizontally from its starting location? Okay, let's draw a little diagram here. We've got one circle and then the exact same circle. Something like that. And we are asked essentially to figure out the distance from the middle to the middle, like that, as this wheel or circle, it's a wheel actually, moves along. So that red line is what they want you to figure out. Well, this question basically says that the wheel is turning one complete revolution. So that means that along the floor of the, what are they calling it, flat horizontal surface, it's going to travel from here and then eventually end here. Now that distance represents one complete revolution. It represents the circumference, c. So the answer to this question is C. But those are not represented in the answer choices. We want an actual numerical value. The circumference is how far this circle will travel. Well, we know that the circumference is equal to pi times diameter. Diameter is 2 times the radius. And the radius they give you is 1. So there you go, 2 pi. And that's it for number 23. They gave you a little bit of a break on number 23. So the answer is C. Rectangles that measure 4 by 2 are positioned in a pattern in which the top left vertex of each rectangle, after the top one, is placed at the midpoint of the bottom edge of the rectangle above it, as shown. When a total of 10 rectangles are arranged in this pattern, what is the perimeter of the figure? So here we go, not perfectly drawn to scale, but here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those 4 by 2 rectangles positioned exactly the way they've described it in the question. So now we will have to figure out the perimeter of this shape. Okay, well that perimeter from there to there, just that part, is 4. Similarly, that part is going to be 4. So we've got to figure out all the sides. This is going to be 2, this is going to be 2, right? Because those are positioned in a way so that they even show you on the diagram that this is equal to that. And since the whole side is 4, then each of those is going to be 2. So let's just count up how many of those 2's we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we've got the perimeter so far looks like 4 plus 19 of those 2's plus the 4 at the bottom. And now let's count the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Which is what I thought. So this looks like 8 plus 38 plus 38, and therefore that is 84. So number 21, the answer is D.